To look at the surface area of a cone, I first want to go back and look at the surface areas of our prisms and cylinders. So we'll set that aside. If we take a prism and try to unfold it to find all the sides that make up this prism. So First I'm going to take those two bases, the two sides that are parallel to each other, and we're going to fold those out. Then we take the rest of this box and we cut this apart so that the four sides unroll. And so what we're left with here, let me zoom out just a little bit. And so what we did for the surface area of the prism, we found the area of one base, and we had that same size of base, so we had area of the two bases, and then we had the perimeter of that base. So if we take those four sides of the base and unroll it, those four sides make the length of this one giant rectangle. So the perimeter of the base is multiplied by the height, that distance from one base to the other. So we had two bases plus the perimeter of the base times the height. So when we went to a cylinder where we had two circles on the bases, again, the surface area, we have the two bases that basically they each fold out. And then if we cut from one end to the other, we see that as we unroll it, it also makes a rectangle. Now the length of that rectangle is the circumference of that base. The distance around the base, around that circle, unrolls to make the length of the rectangle. So that's where we did the 2 pi r, the circumference of the circle, the perimeter of the circle, times the height, that distance between the two bases, is a length and the width of this rectangle. And so you have two of the bases plus the perimeter of the base, the circumference of the circle, times the height. Now, as we look at the cone, this is where I'm going to ask you to have you create a cone. And so what I want you to do is find a piece of paper. It can have writing on it, it doesn't matter, it can be magazine page, whatever. And then find two different sizes of circles. So this could be cups, pans, bowls, other containers, anything that's circular. But the two of them need to be different sizes. And so the first thing I'm going to do, and the other thing to gather, a pair of scissors. You can tear, that's okay, but if you have scissors, use those. So pause the video if you need to. Go get two circles, piece of paper, pencil, and scissors. Once you have those, you can unpause the video. The first step is on this piece of paper, whatever type of paper it is, could have lines. I want you to trace around the circle the big circle. Make sure that you leave room so that your two circles can sit right next to each other on the paper. So there's one circle. Then take your other circle and making sure that those edges touch sort of in one spot, trace your second circle. So that you have two circles next to each other just touching basically in one point. So now, before we do anything further, I'm going to attempt to find the center of that circle. I'm second guessing myself on what's going to be easiest. What I'm going to try to do is find that longest diameter of the circle, and I'm going to draw that in two different directions. So where is that longest part of the circle? So that way I know where the center is. That's the goal. Hopefully we can be pretty accurate. Mine's not quite centered, but it's close. Might try and find a better one here in just a moment. So now we're going to take the scissors and we're going to cut these out, but I'm going to leave them connected here. So I'm going to leave a little bit of a space here where they're connected to each other. So you can pause the video and cut it out. As I'm cutting, notice I don't want to cut those two circles apart. I want to leave it close as I'm cutting around. So now I have the first circle basically cut out except for a little piece connecting. Now I'm going to cut out the second circle. So the second circle, I don't necessarily feel like I did as good of a job, but it should be good enough. Now, one way that I can sort of check to see whether my center of the circle is good, and mine is not quite as good as I would like it to be, I'll zoom in a little bit here, is to take your circle and fold it in half. Fold it in half, unfold it, and then fold it a different direction in half. The place where those two folds meet that's actually where my center of my circle needs to be. So that's probably a better technique than what I did that first time. It'll give me a better, more accurate center. Because now what I want to do is to form this into a cone, I need to cut this as sort of a straight line here. So maybe I'll cut along one of my creases right to that center point. So you could go either direction with this one. I'm going to put my writing side in. And so I'm going to have the little circle is going to be the base. The center of my other circle is going to be the top. And I need to sort of roll. It'll be easier if I do this. As I start to overlap those points, the more I tighten this up, the closer it's going to be to being the size of my other circle. So I'm going to keep rolling it. Till I feel like I have this about that size. I'm really pretty close here. Probably good enough. Okay, so now what I want to do is take this edge that's on the outside, and I'm going to draw a line here to show this is how much of the surface is actually showing. So as I unroll it, these other lines that I drew are kind of distracting now. I'll get rid of those real quick. So my cone was just formed from here to here. So this circle, so as I spin it around till I get to that line, that line that was the radius of the circle is now the slant height of the cone. And so the slant height of the cone tells me the radius of that circle that made up the cone. But I'm not using this whole area of the big circle. I'm only using part of it. Well, the way to figure out what part of it is actually being used, we could measure this angle, but sometimes when you have a cone, it's hard to pull it apart to measure that angle. But what we can do is, because we know from this radius, that gives us, we can figure out the area of the whole circle. And so we want to figure out the fraction of that. Well, look at the circumference. The circumference of that section, or the distance around that arc, compared to the distance around the whole thing, that tells you what fraction of the circle we're using. If it doesn't make sense, don't worry about it. It's not going to be the end of the critical piece here. But what I'm going to do is I'm going to cut off this part of the circle that wasn't used, and all that's making the circle is this. It'll help if I fold that. And so that part of the circle helps make the cone. Okay. So to find the surface area of a cone, we have this little circle here, which we can just find the radius of the base, but we only have one of these little circles, so we just have pi r squared. That finds this circle. The other section, which is the lateral face, the outside face of the cone, this one, we are finding the fraction of this whole circle, the fraction of the whole circle. And so we're taking this part of it, which is the circumference of the base. The circumference of the base is the length of this arc. So that is, because the radius of the base is r, that means 2 pi r is this length. The circumference of the little circle is this outside arc of the lateral face. But the whole circle, the whole perimeter, would be based on the slant height, which we often use in L. I often use a cursive L so that it doesn't look like a 1. And so 2 pi r compared to the circumference of the whole thing would be 2 pi times the slant height. 2 pi times the slant height gives you the circumference of the whole thing. So this tells me the fraction of the circle that I'm using, because that's the fraction of the area I want to use. So this is telling me, you know, is this 1/4 of the circle? Well, it's a little bit more than a fourth, maybe not quite a third in this case. But it tells me the fraction of the circle, and so I want to multiply it by the area of this big circle, which is pi times, well, the radius of this circle is L, the slant height. Pi times L squared. So we'll zoom in here on the formula. So this simplifies. The 2's cancel each other, the pi's cancel each other, and now you have r pi L squared on top and L on the bottom. So the slant height on the bottom cancels one of the two slant heights on the top. And so you have pi times the radius of the base times the slant height is all that's left from this. So if you got lost on all of this, the end result, surface area of a cone, is the area of the base, pi r squared, plus all that slanted side is pi times the radius of the base times the slant height of the cone. That's the formula that you use for surface area of a cone. Alright, so what I would like you to do is take that part of a cone that you made and actually tape it into a cone. So if it helps to take your measurements, you're welcome to do that before you tape it together. I need to go grab tape. So if you have some Scotch tape or some sort of masking tape, use it. If you can't, if you have some glue, you could use glue. If you don't, if you have a stapler, paper clip, piece of needle and thread, or just use your fingers if you can't find any of those. But I want you to try to put together your cone, and so if you wrap these sides together and then line those up. So I'm going to take a piece of tape that's about the length of this side. It doesn't have to be quite that long, but close. So I'm going to put a piece of tape along there, and then I'm going to wrap this together, try to line up those sides, and attach that piece of tape. And then my base will basically hold itself, but I'll take a little piece of tape to hold it down If you fold it, this might be optional, that you can get it to hold well enough without the tape. So I get a piece of tape on there, fold it over, if you want to put more pieces of tape you can. Need to crease it a little bit better so that it kind of stands. Maybe if I take another couple pieces of tape, that will help it out. Okay, so once you have this put together, take a picture of your cone that you created. Building things with scissors and paper and tape or glue, it's always a technique, a skill that's good to have. Okay, there's my cone. Alright, so to find the surface area of this cone that I just made, I need to measure the slant height. So I line it up with this at 0 on the one end of the slant height, and it looks like 5.3 centimeters. So I'm going to say my slant height is 5.3. And now I need the radius. Well, as usual, the radius is harder to measure, so sometimes it's better to go with diameter. So the farthest across looks like about 3.6 centimeters. So if the diameter is 3.6, the radius is going to be half of that. So the surface area is pi times 3.6 divided by 2 is 1.8. And then I have pi, again, the 1.8 is the radius, 5.3 is the slant height. So, grab my calculator, and I type in pi times 1.8 squared plus pi times 1.8 times 5.3. And I find that the surface area is 40.149. The 9 means that it's closer to 5. So 40.15 centimeters squared. 40.15 centimeters squared is the surface area. Which reminds me, when we were finding volume, I said that the centimeters were squared. That's not true. I'm looking for cubic centimeters. Right. So I want you to find one other cone somewhere in your house. So you made one. If you really want to make a second one that's different sized, you can. But you can also look around your house to find something else that is a cone. Perhaps, as I was looking around, the tip of a pencil, my mechanical pencil, just the top part beyond the orange, that makes it pretty much a cone. Or I've got a big orange. Can you see it? maybe. There's another cone that my son likes to use to play sports with. So look around your house, find a few other cones. And so you have one that you built, and then one other that you can just measure to find volume and surface area and add them to this Google Doc. Have fun, good luck.